Welcome to this explainer. Have you ever actually stopped to wonder what's happening inside you the exact moment your feet hit the pavement? Today, we're going to unpack the absolutely fascinating biological and anatomical journey that takes place in your body during cardiovascular exercise. You tie your shoes, you head out the door, and you start moving. It seems simple, right? But beneath your skin, this invisible, incredibly coordinated upgrade is taking place, literally transforming your biology with every single step.
Okay, let's dive right into a problem we've all faced, that intensely physical sensation of getting completely, totally out of breath when you first start a workout. You've just started a jog, and within, a few blocks, your chest is heaving. Well, what you're experiencing there isn't necessarily just a lack of fitness. It's actually a massive, sudden stress test. Your cardiovascular and respiratory systems are just thrown into overdrive, scrambling to meet this explosive demand for energy that your resting body simply wasn't prepared for.
But before we map out the exact timeline of a workout, we really need to establish our baseline metric here, which is lung capacity. This basically determines how much raw oxygen your system can handle at any given moment. Think of it kind of like the size of your biological engine's intake valves. It's the maximum volume of air you can physically pull in to fuel the upcoming fire. And obviously, the larger the capacity, the more efficiently your engine can run when the demands get really high.
So, here is our roadmap for today. We'll be tracking the exact path of oxygen from the lungs in motion to building stronger breathing muscles and upgrading the gas exchange. Then, we'll look at fueling the hardworking heart and finally, pushing your anaerobic threshold. All right, Section 1, the lungs in motion. Let's start our anatomical journey right at those intake valves.
The scientific data we have on this is just crystal clear. Lung volumes and pulmonary flow rates physically expand and improve after a dedicated aerobic training program. Your lungs, they don't just passively inflate and deflate like standard rubber balloons. Their functional dynamic volumes actually improve when they're subjected to the stress of aerobic training. By pushing your limits and forcing that heavy breathing, you're causing desirable physical changes in the lung tissue itself. It makes every single breath you take more efficient over time. And you need that efficiency. Because during intense exercise, your body's oxygen consumption has to surge up to a staggering 15-fold from its resting rate. Think about that. Right now, as you're listening to this, you're probably consuming about 250 milliliters of oxygen a minute, but during peak exertion, your ventilation scales proportionally. It jumps from a resting baseline of roughly 6 liters of air a minute to over 100 liters. Imagine actively trying to fill up 52-liter soda bottles with air every 60 seconds. That is the sheer mechanical volume your respiratory system is processing just to keep you moving. Section 2. Building stronger breathing muscles. Let's see how moving all that air physically builds up your respiratory strength.
Just like doing heavy dumbbell curls builds up a bicep, consistent aerobic training acts as literal physical resistance for your diaphragm and intercostal muscles. Think about any skeletal limb muscle. It tones and grows with weight resistance, right? Well, your respiratory muscles are actually no different. When you force them to work harder and faster during a run, they adapt to the strain. The tissue structurally changes. It gets thicker, stronger, and far more fatigue-resistant over time, which is what allows you to sustain that heavy breathing without your chest muscles just totally giving out on you.
Now, have your legs ever suddenly felt like heavy blocks of lead during a run? You can basically blame the metabore reflex. This is a fascinating survival mechanism built right into your biology. When your breathing muscles become exhausted, they trigger a reflex that literally steals blood flow away from your legs and arms just to keep your vital lungs functioning. Your body prioritizes taking a breath over running. However, aerobic training strengthens those respiratory muscles so they don't fatigue as quickly, and that permanently delays the metabore reflex, meaning strong lungs are actually the secret weapon to keeping your legs moving fast.
Okay, moving to Section 3, upgrading the gas exchange. We're zooming down to the microscopic level now. That increased cardiac output we talked about, it acts like a master switch, forcing open previously unused microscopic capillaries. First, as your heart pumps harder, it recruits these closed vessels surrounding your alveoli, those tiny little air sacs deep inside your lungs. Second, with way more surface area suddenly available, oxygen rapidly crosses the capillary walls directly into your bloodstream. And finally, carbon dioxide is efficiently pushed out of the blood and expelled back through your lungs. It makes your whole internal gas exchange incredibly streamlined.
But the really cool part is that the benefits last long after the workout actually ends. The rush of increased blood flow causes physical friction, what we call shear stress, against the inner walls of your blood vessels. This triggers the release of nitric oxide and promotes a specific protein called VEGF, which literally builds brand new blood vessels. It's a biological process called angiogenesis. These microscopic structural changes shorten the physical distance oxygen has to travel to reach your muscle fibers. And that, right there, is exactly why you no longer get winded going up a flight of stairs.
Section 4. Fueling the hard-working heart. Let's follow those newly built fuel lines directly to the central pump.
Okay, consider this staggering number. The heart muscle extracts 75 to 80% of the available oxygen from your blood even when you are just sitting perfectly still on the couch. Most other organs, they extract a tiny fraction of that. This means your heart is already running highly optimized, kind of like a car engine idling near its red line. It leaves almost zero reserve capacity to simply pull more oxygen out of the existing blood supply when it starts beating faster during a sprint.
So, because the heart can't squeeze much more oxygen out of each drop of blood, aerobic exercise forces an absolutely crucial physical adaptation. Coronary blood flow must increase up to 5-fold during heavy exercise to keep the pump running. Your body pulls this off through vasodilation, physically widening the coronary arteries to improve oxygen delivery to the heart tissue. This prevents ischemia, which is a really dangerous and painful restriction of blood supply. Over time, regular aerobic training permanently improves how effectively your arteries dilate to protect and fuel your central pump.
And finally, Section 5. Pushing your anaerobic threshold. Let's look at the ultimate payoff for all these upgrades.
To really understand your limits, let's use the highly relatable talk test. At your first ventilatory threshold, or VT1, your exertion is about a 4 out of 10. You can comfortably hold a conversation and your body is happily burning fat for fuel. But push harder to VT2, your anaerobic threshold, and exertion jumps to a 7. You can only gasp out a couple of words, and your body desperately switches to burning carbohydrates, driving that heavy, burning breathing as acid starts building up in your muscles.
So this is the big picture payoff right here. By building a stronger diaphragm, increasing your microscopic capillary density, and drastically improving your heart's efficiency, you physically push your thresholds higher. You actually train your body to stay in that comfortable, fat-burning VT1 zone at much higher speeds. You can run faster and longer, delaying that painful transition to your limited carbohydrate stores at V2. You've essentially upgraded the engine so it can cruise at highway speeds without overheating. As the scientific literature reminds us, microvascular networks are among the most plastic structures in adult biology. Your lungs, your heart, your blood vessels, they aren't fixed, rigid pipes that just wear out over time. They are highly adaptable, dynamic systems, just waiting for the right stimulus to remodel, expand, and grow stronger. Your body is quite literally built to rebuild itself.
So as you think about that incredible anatomical journey, from taking a single breath to crossing a finish line, what invisible internal upgrades are you going to trigger tomorrow? Remember, every single time you get winded, you aren't just suffering out there. You are actively triggering a massive, life-extending biological upgrade. Thanks for joining me on this explainer, and hey, keep moving.